guys are smart, so I have to round it back down to. All right. No, I was very proud of y'all. Did well. Sam forgot to do a part of a page or a whole back page. Yeah, you can't take Sam with us anywhere. All right, so I think at some point I had assigned 9E. Would that be about right?
Yeah.
That was like so last month. Do what?
9E or F?
What about F?
That's
F was the review, right?
No, that was
E. E was review. F was what I want. Hey, thank you. He's here. Dude, man. So F is what we need to do?
yeah.
Listen to this. This is funny. You failed to attend supervised study yesterday. If you don't attend supervised study today, you risk being suspended.
Just called you out.
That kind of stuff's just funny to
I
me.
went yesterday.
No, he's fibbing. I'm just kidding.
He's gonna suspend you, man.
And he's thinking, sweet, I can go, man, Fortnite for the next 3 days.
Bro, they're like on one, and I'm like, gotcha.
All right.
Brand, he's lying, man. He won't suspend you. Don't feel the supervisor.
That's what I'm saying, bro. Just sit in your car and blame this.
Just start blaming other people. It'd be good. You'll be fine. I'm just giving you a hard time. Thanks for letting me. I hope you don't hate me for making fun of you. It was funny. All right. Oh shoot! Get out of there. No, wrong thing. That's good stuff. Got a smiley face up there. Works. All right. So 9F was what at some point I had assigned, right?
Yeah.
Okay. So that'd be what I would need to collect next. Okay. So let's take a look at 9F. 9F. No, it was so last month.
So last month.
It's like Friday, Thursday, somewhere in there. Seriously. You need an extra day, it's fine, but let's go over any questions you might have on 9F.
9.
Number 9 on 9F.
Yeah.
Okay. Number 9 on 9F is -5 to what value would equal 1/625. Okay. So, is the negative going to be affected by any exponent? Or is just the 5?
Just the 5.
So, can I plug a number in
Yeah.
and first off, make it a fraction. So just so we know, there could be a negative that we plug in here. That'll flip it over. And I know that 5 to the 4th is 625. Now, let me ask you this. Is -5, or so, that becomes 1/5 times 1/5 times 1/5 times 1/5. All of them are like that. So that gets me 1/625. How do I get a negative out of it? Can I make a negative answer? No. Right. What is this? I don't want that.
So no solution.
That is a no solution all day long. Okay? So this one's no solution. Because this is interfering with us, this has got to say no solution there. What else on 9F? What else on 9F?
52.
52. You're just shooting fish in a barrel, aren't you?
Yeah,
There's not 52 questions.
Yeah, there is.
I'm glad I didn't do it.
You're a big jerk, man, making us do all this work. All right. So if we remember, we want to turn our bases, our 27 and our 1/9, we want to get it to the same base. So I can't turn 27 into base 9, but I can turn 27 into, I can make this 3 to the 3rd, which means this is going to become 3 to the 3x plus 18. Does everybody agree with that?
Yeah.
Now, I don't want to have 1 over 9. I'm going to have 9 to the negative 1. But how do I make 9?
3 negative.
Yeah, so I'm going to convert this to 3 to the negative 2. Is that okay?
Yep.
Yeah.
And that means I need to distribute that negative 2. So I get negative 4x plus 2. Does that seem okay so far?
Yeah.
So now I have 27 as base 3, and I have 9, 1/9 in base 3. So then I'm just going to set my exponents equal to each other. And like, this is so like 2 years ago math. Algebra 1 stuff. So 2. So subtract 2, so that becomes 16. Subtract that, I get negative 7x. So x has to equal 16 over negative 7. Of course, I could have negative 16 over 7 as the same answer. That's good stuff. What else would you like to see of those 52 big, mean, bad teacher giving you problems? Good?
You do 33.
33 from the back.
No, 33 is
33 on the, no, 33 from the back of the class to do on the front page of 33. 33. 4 to the x is equal to 64. Okay, couple things. Can I make 64 to be base 4? 4 times 4 is 16, times another 4 is 64. So I can turn this here into 4 to the third, because 4 times 4 times 4, and I can turn this into that. So then I find that x equals 3. Done. I could have turned them both into base 2, and the answer still would have been the same. Anything else? We good? All right. If you have 9F all done, don't turn in some, 3 problems and he'll give me full points because he's a nice guy stuff. Or anything else that you might need to turn in. I did not collect the review. The review was 9E. Don't turn the review in. I don't want it. Don't turn the review in. You guys keep it. Study for the final on that one. You guys got like 87% average grade on quiz in here. How am I going to go?
Were you expecting a lower average?
No, this is what I'm worried about. So come Thursday morning, we all got to sit there in the PLC, and I get to listen to Mattis Ritz going, well, my average was this. And then I get to hear Kim Schumann-Smith saying, well, my average is this. And then I get to hear Mrs. Peterson say, my average is this. And then I get to hear Mr. Evans going, I haven't given it yet. And then I get to hear Mr. Gee say, well, my average is this. And then I'm sitting there going, okay, we did way better than everybody. Why? How can I make this sound good? And so then I actually will have to probably lie during it so they don't say, oh, you're just an easy grader. Because I'm not an easy grader. No, come on. You guys are just good students. You guys make the job easy because you seem to absorb it. So is there homework was passed up? Anything passed up over? Anyone's passed up? Some come. Just slap him in the head. Give him a paper cut on the back of the neck or something.
Me?
So let's take a little historical adventure.
I love the class.
So the historical adventure I'm trying to get y'all to realize is the math that we're doing today was developed during a time where they started realizing, you know what, these really, really big numbers aren't a lot of fun to multiply and divide. And so we need to figure out something that deals mainly with the exponents, because the exponent of a number is short. It's not my fault your genetics has you short.
True. That's fine. You're too short. It was too.
Alright. And I gotta come collect homework. So I want you to think about it. All of the really big numbers that you have out there, a lot of them can be represented with having a low base to an exponent. And an exponent allows a number to grow really quickly. Does that make sense?
Like stuff in science.
Yeah. So they started recognizing distances that were these great far distances that you can start representing, saying, oh, we have an exponent that we can have a small base to, and that exponent means even 2 to the 50th power is a huge number.
Huge.
Okay? But if we had 7 to the 256th power, there's not a calculator out there that's going to compute that because it's going to run out of space. So he started looking at the exponents and started realizing when they were trying to determine how far things were, they used a process called triangulation. They did it in outer space to figure out how far planets are from each other, stars are from each other, how far we are from the sun, things like that. We didn't have a big old tape measure measure it. And they used this type of math, and they started realizing, well, crud, we invented these exponents so we could sit there and say, hey, it's 4 to the 5th away from us. And then we had to start realizing there needed to be something to bring the exponents down front, so they developed something called a logarithm, L-O-G. Okay, and a logarithm and natural log, they basically do the same thing, and they started realizing there's a whole lot of stuff in the real world that actually takes place because logarithms. Okay, they can use the math to define what happens. You've heard of earthquakes. I know we don't get many here. But earthquakes are measured by something called the Richter Scale. And the Richter Scale is based using a log. Okay? I have been in a few earthquakes. And I would strongly encourage you, if you haven't been in one, go to a state that has them and be outside when it happens. So you can't really predict. It's a strange sensation.
Does it feel like? It's kind of weird. Those machines that shape like that,
Well, I've been in a couple. I've been in the ones that are a jolt, where it's you're standing here and it jolts, and all of a sudden you're standing here in your room going, "What just happened?" And I've also been in the ones that just comes out as a seismic wave, where you're kind of sitting there and it feels like you're in the ocean. It's like, woo! And the house that you're in is doing this still. And you're like, what's going on? I don't know. So, I don't know if y'all know this, but the northern part of Nevada has the highest amount of earthquakes to anywhere else in the world. They average a freakish amount of earthquakes per day that do measure on the Richter scale. You can't feel them all. But I was in one that was about a 5.6, and it was the big wave one. And it was so strange because it was right before we moved here. And both kids are up for nap time. And I'm sitting in the kitchen. It's during summer, and I'm eating something, and my wife is chatting with me. And all of a sudden, the house just feels like a wave hit it. It's like the whole house felt like it went up and then came down. And then you could feel it swaying back and forth. And we're just kind of looking at each other going, I think that's an earthquake. So me, the genius that I am, just in case you thought I was smart, let me just tell you how smart I was. I'm like, dude, we got a for sale sign sitting out front. We have an offer on the house. I got to go check the crawl space to make sure the foundation isn't cracked. So right after the earthquake, I go to the crawl space underneath the 2-story house. And I'm crawling down. Oh, it looks good. Nothing cracked. The earthquake just hit. But I was worried about my financial gains. I didn't want to have to say, yeah, we'll take $100,000 off the price of the house because now you have an 1.5 inch crack in the foundation. So, fortunately, but that's how smart I've been. And so, in case some of you are curious about my intelligence level, hopefully it dropped a little bit now.
Why do earthquakes last a long time?
No, you can have aftershocks.
Oh.
Or we might have had a pre-shock and there might have been the big one coming. So I would have been stuck under the house if it went. I would have been a little skinnier. I would have been so skinny I would have had to have run around in the shower to get wet. I mean,
Flat stand.
So needless to say, this is where the logarithms have come from. Now, this has been around for hundreds of years, of course, but it allowed these other maths to take place and allowed us to define a whole lot of things. So let me go to the front of this. There we go, smiley face. All right, so 10 to the x equals 1. Well, this would have to be a 0. This would have to be a 1, 10 to the first of 10. This would have to be a 2, a 3, and a 4. Do you agree with that?
Yeah.
So then, when you see log just as it is, log is in base 10 form. If it just says log and doesn't change the base, the reason it always defaults to base 10 is because we have 10 fingers. Okay? And that's why we count as a base 10 unit, because we have 10 fingers. That's honestly why it happened. If we had some freak that, if Descartes had like 7 fingers on each hand, we'd be in a much different math predicament than we are now. But fortunately, we didn't happen to happen. All right, so log of 1 is 0. Log of 10 is 1. Log of 100 is 2. Log of 1,000 is 3. Log of I don't know why I have a log of 1,000. That's 3, and hey, that's also 3. It wasn't some trick answer. I think that was supposed to be. So this basically means this is the exponent. All of this is, what would the exponent be of my original in order to get there? Okay? So when you have log base whatever of a number equals something else, the equals something else is the exponent of the base of the number. So let's delve in to see if we can unconfuse you with this. Now we have all this information. I think this is on your paper. It says let b and y be positive, and we're not going to allow b to be equal to 1, because if I have 1 to the third, I have 1. If I have 1 to the millionth, I have 1. So 1 doesn't really help us a whole lot if that's the base. And the logarithm of y with base b is denoted log base b of y, and is defined as pull. Okay, it's already pulled. Log base b of y equals x if and only if b to the x is equal to y. And you're like, huh? How do I define an L and an O and a G? Oh, well, it's logarithm. So they're not exponentials. Okay? Do we need to consider base of 0? No, that should be undefined. Do we just need to consider base of 1? No.
That's just
Okay.
a number.
Yeah, if you had 1 to the whatever exponent, you're just going to get 1 out. Even if 0 is hanging out in there. Okay? So let's try and clear up this a little bit. All right. So log base b of y is equal to x. And then it says bx is equal to y. And I think these are reciprocals. I don't know if I spelled that right or wrong. All right. Now, this is all fine and dandy, but this starts looking really awkward. So let me just show you the easy way. So you can convert things from logarithmic form to exponential form. You can convert things from exponential form, which we did so well on 87% average, back to logarithmic form. Okay? I call this the seashell method. Y'all know the seashell? So ready? This is actually read as log base 2. Log base 2 of 32 is equal to 5. So that 5 is the exponent. So I'm going to start here at base 2, and I'm going to make myself a shell. I know I'm not an artist. You don't have to applaud this time. So that means exponential form is 2 to the 5th is equal to 32. Can you follow the path that I just went on my seashell?
Yeah.
Okay? So again, let's do seashell here.
10 to the second.
10 to the second is equal to 100. Yeah. One-half to the negative 1. Positive 1. So negative 1 is equal to 2. Okay? Can you all see my seashell? And if log is on the other side, then just flip your whole equation over. So 10 to the negative 2 is equal to 0.01. Well, why is that? Well, that's 1 over 10 squared, which is 1 over 100. 1 over 100 is tenths, hundredths. You thought your teacher in elementary school had a speech impediment. Maybe they did. You guys, did you have that elementary school teacher? No, this is the tenths. Yeah. Why are you spitting on me? This is the hundredths. And you're like, where's the one? There isn't one. Why not? I don't know. It doesn't say in the book. The reason why there isn't a oneth is because you can't have base 1 with an exponent changes anything. Cool?
Yes.
There's your answer that you have been waiting for since 3rd grade. 2nd grade for those of you who are advanced. 5th grade for those who are still figuring it out.
I'm still figuring out the basics of algebra.
Hey, I'll tell you, you guys want to know a little secret? My daughters think this is the funniest doggone thing they've ever heard in their life. This was brought up about 4 years ago during dinner. So I'm talking about my elementary school teachers during dinner. And my wife says, yeah, but didn't you go to kindergarten twice? Yeah, sure did. I had a red shirt season of kindergarten. I went twice.
I went to 1st grade twice.
That explains a
That
few
makes so
things.
much
So I call kindergarten part 1. Y'all might have called that daycare. That's what my mom called it. It was free daycare. Yeah, my kid can't even button up his own shorts, but I'm going to send him to school. Go to school. Give him slip-on shoes. He can't tie his own shoes. So I went to kindergarten twice. My daughter thinks it's the funniest doggone thing you've ever heard. She's like, Dad, I don't understand a lot about you. Ah. And then they start spelling stuff to each other. I'm like, I can't follow. So, you guys anytime you want to come to dinner over the store place, it's kind of fun. Our dining room table seats up to 14 when we put the leaves in. Put the little things in the ends. Do what? All right. Hey, so what do we know about the cases below? Well, b to the 0, well, this has to equal 1. And b to the first, that has to equal b.
Oh, okay.
Glad we have a whole slide for that. That seems pretty straightforward. And then, let's see. Let b be a positive real number such that, now we're getting these weird, it's like, well, we're English people now. Such that b is not equal to 1. Where's the therefore in that? In there should be in it. So a logarithm of 1, log base b of 1 is equal to 0. Okay, because b to the 0 is equal to 1. Remember, if you do your snail here, b to the 0, make it exponent form. B to the 0 equals 1. That's why log base anything of 1 is equal to 0. And then log base b of b is equal to 1. Well, why is that? Well, that means that b to the first power is equal to b. So why can't b equal 1? Well, it's 0. We just defined it. Who spit on my glasses? Come on, guys. You can put your thumbprint. Cooper, stop putting your thumbprints on my glasses. That's why. Put his thumbprints on my glasses. Can't see. There's these rainbows in here. It's horrible. All right. Ready? All right. So rewrite each equation exponential form. 3 to the second equals 9. Yay? That's kind of easy. I know 3 squared equals 9. I totally get this. So what's the homework? Well, there's more examples. 5 to the first equals 5. Okay. 1/2 to the negative 2 is equal to 4. 19 to the 0 power is equal to 1. Close though. Stop being like Algebra 1, shouting at any numbers. Okay, what's the vertex of this? Jelly donuts! No.
It was chocolate donuts, but close enough.
Can I move off this screen?
Yes.
Okay. All right. Evaluate the expression without using a calculator. Dude, are you kidding me? All right. So anytime you have this, and then we, take the pacifier of the calculator away, this is what I feel is kind of the best thing to do. Make it equal to x, first of all. Is that okay?
6 is
What?
nothing.
Oh. So I'm going to do this. 5 to the x equals 0.04. This might be easier to look at. They're like, ain't much easier, pal. Still need a calculator. All right, so things I would know about this problem. I know that x, in our case, we had to add an x. I know that my exponent is going to be a negative number. Okay?
Why?
Because 0.04 is 4/10 or 400ths.
Decreasing.
So let's modify this a little bit. 0.04 is 4 over 100. Yay? And then I can reduce 4 over 100 to 1 over 25. So 25 is 5 squared, so I can get 5 to the negative 2. So I get negative 2 for an answer. You follow the work I just did?
Yeah.
So you just want to get down to the smallest thing.
Get down. Yeah.
Get down on it. Get down on it.
All right. So we're going to do this. Ready? 3 to the x is equal to 81. 3 to the x equals 81. 3 to what power is 81? Well, 3, 9, 27. 27 times 3 is? 81. You're close though.
I was right.
Cool. Again, we'll do this. Make it equal to x. 1/2 to the x is equal to 8. Okay? That doesn't look so friendly. So how can I make 1/2 no longer 1/2? I want it to have a multiply by it, make it a negative what? Make it a negative 1. So I'm going to convert this right here to 2 to the negative x. And let me pause there for a sec. Does everyone see why?
Yeah.
If I flip that over, I get a negative exponent, which is negative. And then I'm going to convert 8 to 2 to the third. Of course, I speak at the same start to see that kindergarten twice wasn't a bad idea for me. All right, so I get negative x equals 3, so x equals negative 3. Yes. This is beautiful math.
I don't understand anything.
All right. Well, hopefully 9 to the x equals 3. Okay, how do I do this?
1/3? I mean 1/2?
It could be. So let's convert 9 to base 3. What's 9 in base 3?
3 times
3 squared. So this becomes 3 to the 2x equals 3 to the first, because I can have 3 to the first there. So then I get 2x equals 1. So x equals close, 1/2.
Oh.
It's like
So you
3
just simplify them to the same
Get the
base
same
and
base.
then take the x.
Does everybody see the seashell?
Yeah.
Cool.
Seashell, she-shell, down by the...
Seashore. All right. So, common logarithm. So, if you have log base 10 of x, you can always default to say just log x. Again, I'll say that. If you have log base 10 of x, you can default to say log x. It means the same thing. If I do log base e, remember the exponential that we did so well with, 87% on this last quiz? Log base e of x is the same thing as the natural log of x. Now, what's cool about log and natural log is they have the same rules. And what's great, because we're lazy people as a nation, when you're doing a math problem and it either requires log, L-O-G, or natural log, Ln, we always choose Ln because it's only 2 letters. That third letter of writing, forget about it.
Man, this must be a woodcutter's favorite type of math.
All right. Solve each expression without using a calculator. Well, this is log base 10, right? If I made that x, I could go 10 to the x is equal to 1,000,000. So 10 to what power gives me 1,000,000? 10 to the 6th? So 10 to the first is 10, 10 to the second, 100, 10 to the third, 1,000, 10,000, 100,000, million. So x equals 6. Agree? Natural log of 1, 0. Log 1 and natural log of 1 are 0. Yeah.
For 9, what's the little thing?
I drew 10 to the x.
Like right, no.
Oh, log base 10. Because
10?
log base 10 is equal to just log. So if I had log base 10 of x and log of x, that means the exact same thing. So I was just throwing the 10 in there so we had the base of my exponent. Natural log of e, these undo each other. 1. Okay? Okay? Hey, this is log base 10, yes? If I make that to the x, I can go my shell. I can go 10 to the x is equal to 0.0001. Well, that's tenths, hundreds, thousands, 10,000. So that's 1 over 10,000. Negative 4. X equals negative 4. Good job. It's negative 4 because this becomes a smaller unit. So 10 to the 4th power is 10,000. 10 to the negative 4 is 1 over 10,000. 1 over 10,000 is 1/10,000. Okay, remember that log refers to the exponent needed to get the value. Yay. All right, let's see, let's solve it. X to the negative 3 equals 27. Agree? Oh, okay. So I want to do this. Agree? So what has to happen to x? If I have an x that's like that, like this right now, it gives me 1 over x to the 3rd. Agreed? So
negative exponent.
So this has to be 1/3. 1/3 to the negative 3 is the same thing as 3 to the 3rd. 3 to the 3rd is 27. Oh, I already know what the answer to this because I've taught math for a long time, but we'll go my snail way. 7 to the x is equal to 7 to the negative 0.32. What's my answer? What's x equal to? Negative 0.32, yeah. So what you'll start realizing is if I have these match, those cancel, your exponent's your answer. Okay. X to the negative 4 is equal to 1 over 81. Okay. 81 is 3 to the 4th. 1 over 81 is 3 to the negative 4. So what's x have to equal? 3. Okay. So the exponents matched up. So you just take the basis, set them equal. And again, I know what this answer is because I've taught math for a long time. But wait, no, I'm not even going to do that. I'm getting rid of that. I don't want that. Log x is the same thing as log base 10 of x, yes? Yep. Does this 10 and this 10, 10 is the same thing as 10, those cancel, so I get x equals 17, done.
So anytime you 10 to the log x, it's just gonna be.
Yeah, so if you had 3 log base 3 of x equals 7, then x equals 7. If this and this match, less than you, Tiny Tim.
Thanks.
All right. Oh, try rewriting the expression in exponential form first. We did. Yay. All right. There's my shell. 1/5 to the negative 3. Blessing you again. X equals. Yay. 1/5 to the negative. That's going to be 5 to the third. So I get 125 equals x. Agree? 1/5 to the negative. Flip it over. 5 to the third. 5 times 5 times 5. 125. Yay. Hey, anyone take a shot there?
No.
No?
X equals 12.
X equals 12, done. Just drop the mic.
Oh, because the stuff cancels out.
Yep. Anyone want to take a shot at this?
X equals 4.
4 equals x, or x equals 4, yeah. Ooh, e and natural log. They undo each other. These undo each other. X equals 17. Yay, done.
That's excellent.
Is there any more homework?
No.
That was it?
No homework.
No homework? No, we have something to do.
You don't need to double check. Yeah.
We got 9G, worksheet 9G.
9Gs.
Yeah, baby.
Hot cakes and sausage. Oh, thank you very little. And thank you very little.
9G.
Wait. Okay, back to the Yes, that way.